Okay, I want you to picture a peregrine falcon, the fastest animal on the planet. It's hovering thousands of feet up in the air. But it's not just a bird, it's really a living, breathing physics problem. Its eyes, which are just legendary, spot a pigeon way, way down below. And what does it do? It doesn't just flap its wings harder. No, it tucks them in, turns its body into this perfect aerodynamic teardrop, and just lets go. It hits over 240 miles per hour. From that moment, it has just about 5 seconds to close the gap between hunger and survival.
And this is where things get really, existentially serious. Because if that falcon guesses wrong, if it hallucinates the position of that pigeon by even a fraction of an inch, it doesn't just miss lunch, it dies. Nature, over 540 million years of evolution, has come up with a system that has a very simple, very brutal standard: zero hallucination, period.
So here's the absolute heart of the matter. The Falcon connects directly to reality to know where its target is. Our current AI, on the other hand, connects to a static library of data to guess where the next word should probably go. And that one single difference, the gap between knowing and guessing, is about to trigger one of the biggest shifts in technology we have ever seen. All right, let's dive into what that really means. So, to really get why this guessing game is such a fundamental issue, we've got to look at our current AI models through a bit of a historical lens. The sources we're digging into today call this AI's Ptolemaic problem. And yeah, that's named after Ptolemy, the ancient astronomer who built this brilliant, incredibly complex, and, well, completely wrong model of the universe that had the Earth right at the center. You see, the funny thing is, Ptolemy's math kinda worked. But to make it fit the data, he had to invent these insanely complex patches called epicycles. Basically, circles spinning on top of other circles. Well, today's large language models work in a pretty similar way, inside what we call a closed manifold. Just imagine a genius, locked in a windowless room, but they have every book ever written. Now, if you ask them, hey, is it raining outside right now? They can't look out the window. All they can do is make a really educated guess based on historical weather patterns. They are literally trapped in a mathematical prison, completely cut off from the real physical world. So for these systems, hallucination isn't some bug that we can just patch and fix later. It's a fundamental feature. It has to be. If you're locked in that windowless room, you have to hallucinate the weather to even try to answer the question. You have no other choice. And if you want to get technical about it, the mutual information, that's the I, between the AI's internal context, C, and physical reality, R, is approximately zero. There is basically no information flowing from the outside world into the model itself. So feeding it more data, that's just adding more books to the room. It doesn't build a window. And this leads to an absolutely insane thermodynamic problem. The energy it takes to train a massive model to guess can cost tens of gigawatt hours. Meanwhile, our Falcon uses mere milliwatts of metabolic energy to know. Think about that. To get a guessing machine from, say, 99% accuracy all the way to 100% truth would, in theory, require an infinite amount of energy. The whole approach is, as the source material puts it, thermodynamically doomed. Okay, so if the current way of doing things is doomed, where do we go from here? Well, what if the answer's been right here the whole time, just hiding in plain sight inside nature's own operating system? Let's take a look at that blueprint. Let's go back to our Falcon for a second. It doesn't just think, it experiences this 5-step loop. First, there's a circumstance. A sensor in its body detects low blood sugar. It's just a neutral fact, a measurable gap. Second, this triggers a thought. I need to hunt. Third, and this is key, that thought creates a feeling, stress. Cortisol, dopamine, they spike, creating the potential energy for action. This stress isn't a bad thing, it's the fuel. Fourth, powered by that stress, it takes action, it dives, and it's constantly measuring reality on the way down. And finally, convergence. The gap is closed, the prey is caught, the stress is gone. That is intelligence in action. And this really gets to the core mistake of our current AI systems, which the philosopher C.S. Peirce actually explained brilliantly. He showed that real meaning is a triad. It has 3 parts. There's the object in reality, a real-life mouse. Then there's the representamen, which is the sign, like the word mouse. But then crucially, there's the interpretant, the meaning that's actually made in the mind of an observer, like the Falcon thinking, that's lunch. Current AI is stuck just connecting signs to other signs, like mouse to squeak, completely missing the link to reality and any actual meaning.
So how in the world do we build a system that actually gets it? A system that incorporates all three parts of that triad? Well, it means we have to start thinking in a totally different way. We have to establish a new kind of physics for AI, one based on a concept the authors of this work called the gravity of meaning. The very first step is to swap out the fundamental building block. We have to move away from the token, which is just a statistical piece of text, to something new called the token. Now, a token isn't a guess, it's a structural unit of actual meaning. It doesn't represent a probabilistic guess, it represents deterministic, verifiable knowledge. We're talking about the difference between correlation and actual causation. And here's a really cool way to understand how it works. A token has a dual identity, kind of like your computer on the internet. It has an IP address, which is its location in the abstract world of ideas, like the medical textbook definition of pneumonia. But it also has a MAC address, a direct link to a specific, verified thing in the real world, like this patient's specific X-ray, diagnosed by this specific doctor at this exact time. It directly connects the map to the territory. So what guides these tokens? The source material calls it agapistic influence. Now, hold on. This has nothing to do with love or emotion. It's a term borrowed from physics. The best way to think of it is like gravity. Just like gravity is a force that pulls mass together, agapistic influence is a force that pulls meaning together. It's a thermodynamic pull toward whatever is true, coherent, and useful for closing a gap and reducing stress in a system. So check this out. Just like a massive object curves physical spacetime to create a gravity well, this agapistic influence function, or AIF, curves semantic spacetime. It creates what you're seeing here, a homeostatic attractor that literally pulls meaning and ideas toward a stable, verified truth. It's a force that, by its very nature, punishes hallucination and rewards verification. So, when you put all these pieces together, a token that's connected to reality, guided by this agapistic influence, what you get is a massive paradigm shift. Intelligence is no longer something you hoard or own or keep locked up. This one image right here tells the whole story. On the left, you've got the old way of thinking, intelligence as an asset. It's a hoard of treasure, billions of parameters, guarded by a dragon in some centralized castle, and it burns a crazy amount of energy just to make a guess. And on the right, you have the new paradigm, intelligence as a flow. It's this dynamic, distributed, super low-energy network that is constantly measuring reality to close gaps. And the benefits of making this shift are just staggering. We are talking about a system that is over 100,000 times more energy efficient, a system that is causal, not just based on correlation, and a system that, by its very design, has zero hallucination. This isn't just a nice idea. The authors argue that it is thermodynamically inevitable. And that brings us to one last, really provocative thought. The authors of this work propose that we've been making a fundamental category error this whole time. Maybe the goal was never to build artificial intelligence at all. Maybe the real future is to build systems that facilitate agapistic influence, keeping the same acronym, AI, but totally redefining what it stands for. A fundamental shift from a machine that guesses to a living network that knows.